Hey guys, my Rishabh. Today we are going to talk about vector quantity. So let's write the topic first. Vector quantity. So why we need a vector quantity? So in dimension for a moving particle, a plus or minus sign, or we can say positive or negative sign, is no longer enough. Therefore we use a vector. So we can say in 3 dimension dimension positive or negative sign is no longer enough. So many of you guys have talked about the handwriting problem here. I will try to improve that. So no longer enough, therefore we use a vector. So what is a vector? Vector has a magnitude as well as direction. So what is magnitude? Magnitude, if you wanna understand magnitude, it means quantity or amount. Quantity or amount. So if we are saying that 40 degrees Celsius, 40 degree Fahrenheit, it means 40 is a quantity. So you can understand this magnitude from this example. And direction is just a direction, which like if you take a reference, positive or negative sign in xy plane, x and y. So if a vector is like this, so we can say the direction of the vector is on a positive x direction. So you can understand the direction. You always this is just a common approach of direction. So moving on, some examples of vector, like what are the examples of vector? Displacement is example of a simplest example of a vector. Velocity and also acceleration, because let's say, what is displacement? I already have described you the definition of displacement, that if there is a starting and ending point like this is a path, starting point and ending point. So starting and finish point. So the displacement is the nearest path or the shortest path is the displacement. So displacement have a particular direction, and it also have a magnitude. This is a amount of magnitude, particular kilometer, or it have a direction, start to finish direction. So this is called the vector quantity. Moving on, the physical quantity does not involve a direction, is scalar. Like the physical quantity, I already have I give you the example of physical quantity 40 degree Fahrenheit. This is just a quantity which doesn't represent the direction, so which only represent by its magnitude is a scalar quantity, like temperature in scalar. You can say temperature and pressure and also energy. All this have only the magnitude or amount of its kind, but it doesn't represent the direction. So I already have told you that displacement is the simplest vector. So let's take some example, moving on, taking some example like if this is a vector A to B, this is finish point, and this is also a vector A dash and B dash, and this is also a vector A double dash, starting point and finish point, A double dash and B double dash. Then the magnitude of all three vectors are the same, so we can say these are magnitude and direction. The A double dash and B double dash doesn't have same direction, but A and B and A dash and B dash have the same direction, so we can say that it is a identical vector. Or and if we wanna understand the displacement vector, if there is a path like this starting to finish, and there is another path like this, so we can say this is the displacement. So what displacement represent here? So displacement vector represents only the overall effect of motion, not the motion itself. It represents the overall effect of motion, that some particle is here and it take this path, or it will take this path, but the overall motion, overall effect is the displacement. Moving on, so in vector we usually move on to adding or subtracting. So we can say adding vectors geometrically. So let us consider A and B and C point. So this is the path, actual path. So we can say this is vector A, this is vector V, the displacement. So the resultant vector will be C. Or we can say the net displacement is is the sum of or vector sum of A plus B, which is resultant, which gives the resultant displacement. Moving on, there are some rules in adding that like if this is the vector, this is a path of the vector, like this vector A, vector B, vector A or vector B. This is the resultant vector. We can say A plus B, and we can say this is vector B because the parallel direction. This is vector B and this is vector B, and this is vector A and this is vector A. So in this way we can say this is B plus A. So from this diagram we can say that A plus B equal to B plus A, which is commutative law. Moving on, let's take another example, like if this is the vector A, this is the vector B, then this vector will be A plus B, vector A plus vector B, and if we consider from there here, this is vector C. Let's take bigger than A for not confusing that this is the same as a B and B. This is not the B. This is it have bigger magnitude. Let us consider it have bigger or different magnitude and direction from A. So we can say this is the vector C. So resultant will be this vector and this vector. So resultant will be here B plus C, or vector B plus C, or here. So what will be this vector here to here? This will give us what this will give us. This is vector A plus B, and vector C, vector A plus B, vector C, vector A, B, vector A plus B resultant. Therefore similarly vector A plus B and plus vector C. So we can say this is vector A plus B plus C. So in here there are two conditions. There are two conditions, like we can take this vector as two different approach, like vector A and B plus C, and vector A plus B and C. So let us consider the first case, vector A, and this is vector B plus C. So it will give A plus B plus C bracket in bracket, and in second case we can take vector A plus B and vector C, this vector, then it will give A plus B plus C. So we can say, from this we can say A plus B plus C equal to A plus B plus C. This is associative law. Moving on, let's talk about negative vector. So the negative vector have the same magnitude but in opposite direction. For example, if we are taking like this is a B vector, so opposite will be same magnitude but in opposite direction, negative B vector. So if we are going to take an example, if we are taking an example like we are considering a vector like this A vector, and let us consider the vector like this, and let's start from let us take this example again. Let us take first negative vector B. So we are taking negative vector B, negative B, and we are taking also vector A like this. So the resultant vector will be resultant vector will be D, or we can say displacement will be here. Displacement will be D equal to A plus minus B, or we can say D equal to A minus B. This is the subtraction of vector. So that's all for today. In the next video we are going to discuss more about the vector quantities. Thank you and bye.